Good day to you, my dear friends. Well, no, actually, it's not a very good day. Again, it's very hot. Hot. Why? Not hot. Hot. I'm talking about the weather. And I decided to start running again, and it's an awful day to start running again because it's too hot. Then in the morning, when I came back after my run, there was no electricity. Then they restored the power, but now there is no water. Oh. But nevertheless, we are going to solve some LeetCode problems, of course. And I want to start with the problem from yesterday. Oh no. Where is it? Combine two tables. Combine two tables. This is our solution from yesterday. Don't look. And I want to discuss some other ways of solving this problem. No, better ways or just alternative ways. Well, first of all, we do not have to use this on thing. We can just do using, and it's a lot shorter. Using person ID. And we don't need these short names for tables. I mean, it's a good practice, and definitely in a real life project we should use names of tables, but for LeetCode problems it's not that important, so let's get rid of them. And this is probably the best way of solving this problem, but of course there is another way of solving it using union of all things. Oof. And you know, the author of this solution, I believe it was 123 Tripathi, a girl from India, I believe. Let's upvote her solution because it is great. I mean, they say that she says that she doesn't use join, but she uses this thing. And you know what? It's very similar to join, and more so that how people did joins until the join keyword was introduced in SQL. Select, right? Select what? Last name, first name. City, state, from, and here we list both tables. From, person, address, where. Probably something like this. Let's see. Person ID. I'm not sure, but let's just check. What do we have? And we have Alice Bob from New York City, New York. Great. So that's how joins were done before joins as a keyword, were introduced. But the problem is that we need not just a join but a left join to solve our problem, because we want null values for people that are not introduced in address table. Not introduced, but presented. Not presented, by present in address table. Oh, it's hard to me. It's hard for me to speak today. It's so hot. Oh. Now, that's gonna be our first statement. Not statement. The first part of our union. Our first query, Let's comment it out for now. And in this query, what do we have? We have people that exist in both tables, in person table and in address table, like Alice Bob, Bob Alice, Bob Alice. Such a cool name. And we want to union this ln1, and ln1 exists only in the person table. How can we union this? Well, let's select person ID from address table. Let's see. Of course, I always forget that it's spelled like that. Okay, and we have this. Something happened. Let's see what's going on. Smart Coder 5 is now following. Only now? I feel hurt. Smart Coder 5. How come? But I'm kidding, of course. Thank you very much. What was I doing? So we have these two people in our output, and now let's do an even more interesting thing. Let's select last name and first name from person where person ID not in this query. What's gonna happen? Yeah, and we have ln1. Ain't it beautiful? But now we have to union these two queries. And it's not gonna work, of course, because there is a different number of columns and these two output results. And ln1 doesn't have city or state. How are we going to solve this problem? Well, we're just gonna add null values manually. And it's green. Ain't it a cool solution? And that's how people struggled before joins were introduced in SQL. I think it's a beautiful example. Now let's continue with another problem. A problem that I solved some time ago, and now I want to discuss it with you. And it's an interesting one. Let me list all the problems. It's an interesting one because it has so many solutions. And some are very easy and some are very hard. And we are going to discuss the easy ones today. But someday in the future, I'm going to explain the hard one. I'm just not ready yet because it's crazy. But let's not jump ahead of ourselves. It's shuffle the array. It's a beautiful one. For now, let's clear everything. So we have array nums, length to n. And the first half of how to explain it? We are going to rearrange this array. It's such a simple problem and such a hard description, I don't even know how to explain it to you. Of course, the best way is to use this example. You see we have nums 2, 5, 1, 3, 4, 7. N equals 3. So, in our output array, we're going to have element 2 and then element 3 and then 5 and then 4 and 1 and 7. So, if it's impossible to explain. Nah, I think I should start a whole new channel just for LeetCode problem descriptions. It's awful. So we have to shuffle. And the easiest way of doing this, of course, is to make a new empty array and then to do something like n times do I. And we are going to put into results nums I and nums I plus 1, and maybe that's it. Of course I have a typo, and that's it. What the hell? Oh god. N plus I. I'm overheated. Now it's green, of course, and we can simplify it a little bit. Let's move it here, or even a little bit more by using push me, and then just touch me till I can get my satisfaction. Yeah, something like this. But there is a way to solve it in a one go, modifying the existing array, but it's so hard. There is a bits related approach that it's not crystal clear for me yet, so I'm going to explain it to you some other day, probably yesterday or day after that. But I'm almost there, so have some patience. Now let's discuss some other ways of solving this problem. And for example, I've seen people doing it with zip method. Do you remember zip method? Oh, it's a funny one. For example, if you have like 1, 2 zip 3, 4, I guess. Let's see what's gonna happen. Yeah, we combine the first element of the first array with the first element of the second array, not combine, pair in one array, and then we do the same for all the next elements. And of course we can flatten after that. Now we can take nums from say 0 to n minus 1 and zip it with nums from n to minus 1 and then flatten. Of course. It's a typo. Excuse me. It's green and it's a one-liner, but Jesus, where is it? We create this array and we create this array and then we create a third array with pairs and then we flatten that third array. It's so many unnecessary actions, and all these actions are, it doesn't matter if we have a big O of n or big O of like 4n in terms of big O. It doesn't matter that much. But in the real life, why do we need all these unnecessary actions? Of course, we want to get rid of all these actions. And in terms of space, we do not create all these extra arrays. So it's a fun approach. It's a one-liner, but I do not recommend it. Another approach would be to use inject method from yesterday. And I told you that it's an equivalent of JavaScript reduce method. And it's not only equivalent. In Ruby, you can also use reduce method. It's a alias for inject method. So let's do this. How? I don't know, let's take a range I'm not sure, but let's see. Because reduce method or inject, as it also called, it can be used not only with arrays but with all, how do we call it, enumeratables, So it's gonna work with range too, probably. We'll see about that in a moment. Oh, and yesterday I tried to do this without curly braces. We can do it like this, but also we can do it like this and with the end. And of course here we have to specify our accumulator. call it results. And our current element, let's call it L. And yesterday I tried to do the same thing, but I used round brackets and everything broke and I didn't understand what is going on. The problem is I do too much JavaScript these days, you know. So, what can we do here? Let's say we want to put into results push let's call it not element but I, because it's an index, nums I, and of course nums n plus I, and we are going to return results, and maybe they are already returned in this line, I'm not sure. Let's see. It's green. Haha, nice. So that's another way. And it's not too bad in terms of like time and space. Yes, we create this range, but other than that we have a results array. Well, yeah, I think I still prefer my first solution, which is, let's go back. Oh, and we can do, wait a second, let me think. Yeah, let's simplify it even more, and we do not need and now we can do -1 and wait, not minus, underscore of, I don't know what's going on with me, and it's green. So this is my favorite solution probably, except for this complicated one about bits that I'm going to explain to you some other day. Whew. And we have time to solve one more problem, something new. And I intended to try medium problem today, but because of all these difficulties with power being cut off and so on, I do not have time anymore, probably. So let's start with something easy, and maybe it's not going to be easy at all, you know, it happens sometimes. We ended up at page number 5, and it's a minimize string length string problem, and we are given a 0 index string s. Repeatedly perform the following operation any number of times. Choose an index I in the string and let C be the character in position I, and delete the closest occurrence of C to the left of I if any. and the closest occurrence of c to the right of I, if any. Your task is to minimize the length of s by performing the above operation any number of times. It sounds so complicated. And return an integer, denoting the length of minimized string. Again, there is some kind of a trick to this problem. You just have to find it. So we have a string AAABC. CBBD, DDD, AA. So I think we have to count everything. Let's look for this example. For this we can start with the character b at index 1. There is no occurrences of b to the left of index 1. There is 1 to the right, index 2, so we delete the b at index 2, CBD. Yeah. So let's introduce this hash, which is not a good thing probably. Okay, let's do this. S each do letter, and if hash has a key letter, we are going to we are going to increase the count by 1, else we're going to do that. Now it's not beautiful. Let's see what we have here. 3111. I have a crazy idea. Or not. So if it's two letters or three letters, wait a minute. What do we want to return? Wait a second. Just the number of unique letters. That's what we are going to have in the end. Yeah, but do we need all these problems with hash? How can we count individual letters? Of course, there is a very simple way. Simple in terms of like we have a string and we can do chars and we can do unique and we can do count, and that's about it. But in terms of big O, it's awful. But is it better to create a hash? I don't know. Do we need chars or we can do unique on a string? I don't remember. This question already was raised a few streams ago, but I don't remember result. No, it's not unique. It's chars unique count. This way we create an array . Yeah. But okay, it is solved. For now, I'll take it. And of course it can be done with hash, by the way. Let's done it. Let's do it. Yes, chars each do again as it was. Do we have any drops? It's so hot again. I'm somewhat worried about the performance. So if hash key letter then we do nothing. If no hash key letter then we add it. What? Something like this. But also count equals 0. Increase the count by 1. We can put pretty much anything here. We do not check. Oh no, let's return count. Yeah, it's green too. But is it a good practice to create a huge hash? Not huge. Oh, we had just a string and now. But I'll answer this question tomorrow. As always, tomorrow we are going to discuss the best approaches to this problem, to some other problems, and definitely start something new. And if everything is good, like with power, with water, with weather, then we are going to try a medium problem. Thank you very much for being here. It wasn't probably very entertaining, but we did it. Another problem solved. Thank you very much, and I'll see you tomorrow. Bye.